In this program, we'll fade an LED brightness from 0 to its maximum of 255 and then back down to 0 with analog write and for loops. In the void setup function, use the pin mode function with arguments 3 and output to set up your single color LED. Because we're using analog write, make sure your LED is plugged into port 3, 5, 6, 9, 10, or 11 on MakerBoard. Within the void loop, we have a for loop, and a for loop has four main parts. First, a variable that's created. Second, a condition that's checked every time the for loop runs. Third, a change to the variable that happens after the code between the curly braces runs. And fourth, the code between the curly braces that runs when the condition of the for loop is true. In this case, we're using the int or integer type variable, and that means that our variable value can only be whole numbers, no decimal places. And I'm naming that variable I, which is commonly used as a counter variable inside for loops. After a single equal sign, we'll give that variable a starting value of 0. Our condition checks if I is less than 256, and if that's the case, the code between the curly braces will run, and then I is increased by 1 with this I++ code. Between the curly braces of this first for loop is an analog write function, and that has two arguments: the port where we want to send the analog write, and the value we want to analog write. Remember, an LED can show analog brightness values from 0 to 255. So we can send any value between 0 and 255, like 126 for about half brightness, but instead of using a number here, we're going to use the I variable, which is going to change each time the for loop runs, giving us a nice fade up of the brightness. After the analog write function, there's a delay function with an argument of 25, so the code will pause at each brightness level for 25 milliseconds or 0.025 seconds. Before the for loop ends on line 13, I++ increases the value of I by 1, and the condition is checked again. After this for loop runs 255 times, it will end, and the code will jump down to the next line of code that can run, which here is another for loop. This for loop has another variable I, and it's important to know this variable is completely different from the variable on line 10. They're not related at all, and this has to do with a concept called variable scope that we won't cover much. But know that the integer I created here is completely separate from the one we made earlier. This variable's starting value is 255, and as long as I is greater than 0, the code between the curly braces will run, and then I will be decreased by 1 with I minus minus. So I minus minus means that I equals I minus 1. The code between the curly braces of this for loop is again analog write using arguments of 3 and I, and then a delay of 25 milliseconds. Let's run through how this void loop will work once you have an LED plugged in. You'll create an integer I that starts at 0, and as long as I is less than 256, the code between the curly braces will run. 0 is less than 256, so the analog write function will send a brightness value of 0 to port 3. So the LED is going to stay off the first time the for loop runs. After a delay of 25 milliseconds, the for loop ends, and I++ makes I equal 1. The condition is checked again. Is 1 less than 256? It is, so the code between the curly braces will run, and analog write will send a value of 1 to port 3, barely turning on the LED. There's a delay of 25 milliseconds, the for loop ends, and I increases by 1 from 1 to 2. The condition is checked again, and the code between the curly braces will run again. This for loop is going to repeat 256 times until we have a I value of 255. Then we're going to send 255 to port 3, which is full brightness on the LED, and after a delay of 25 milliseconds with that full brightness value showing, the for loop will end and I++ will move the variable I from 255 to 256. 256 is not less than 256, so the code inside the curly braces of the for loop is skipped, and the code is going to look for the next line of code it can run, which is line 18. Remember, the LED is on at maximum brightness at this point. We have an integer I that's set to 255, and as long as I is greater than 0, run the code between the curly braces and then subtract 1 from I. So the analog write command will run, sending a value of 255 to port 3. So for the first run through the second for loop, the LED is going to stay at a max brightness value of 255. After a delay of 25 milliseconds, the for loop reaches its closing curly brace, and I subtracts 1 from the value of I. Now I equals 254. 254 is still greater than 0, so the code between the curly braces will run again, and analog write will send a brightness value of 254 to port 3, making it slightly dimmer than it was before. After a delay of 25 milliseconds, this for loop ends, and I subtracts 1 from I. This for loop will run 255 times until we have an I value of 1. After we analog write an I value of 1 and delay 25 milliseconds, the for loop will subtract 1 from 1, and now I equals 0. When the condition is checked, 0 is not greater than 0, so the code between the curly braces is skipped, and this second for loop ends. The code will now find the end of the void loop with this closing curly brace on line 24. Then it's going to jump back up to line 10 and start running this for loop again. Remember, the LED is completely turned off at this point, so when I is set equal to 0, the first time that analog write runs, it's going to send a 0 value to port 3. Because these for loops match each other, going from 0 to 255 and then 255 down to 0, it's going to be a very smooth fade from an LED that is completely turned off to complete brightness to fading back down to completely turned off.